All right, so we are going to talk about Module 7 today. I'm going to, again, just kind of walk you through some of the first few slides. So our first example with Module 7 is talking about weight loss. So it says, suppose you are given the following table relating Brandon's weight in pounds to the number of weeks since he began a diet. So I've got that table there, weeks, and his weight. And so the first question is, are those quantities related by a constant rate of change? So we have two ways we can go about it. So one, I can just look at the table and tell you the answer is no. And here's why. Is I see here that Brandon's weight goes down, but then it goes back up, and then it goes down. So as time is increasing, his weight goes down, up, and down. There's no way I could have a constant rate of change because that number is decreasing, then increasing, then decreasing. If you didn't see that, you could do the math, and so you could find the change in output over change in input, so change in weight over time. So I could do 187 minus 196, which is where I get the -9. I could do 2 minus 0, I get 2. Right? I could find this change here, which is a +3 divided by 7, and then this change here, which is a -6 divided by 5. And so no, none of those are the same, so I can say not a constant rate of change. So this is the case in a lot of life. We don't have a constant rate of change. Oh no, we can't do anything. That's not true. So even though those quantities aren't related by a constant rate of change, the rates that we're finding still mean something. And so essentially, when that rate is not constant, the rate of change that we're finding, we call the average rate of change. So we can find the average rate of change between any 2 points, simply just by finding the way we would find constant rate of change, right? The change in output over change in input. So let's do that for this one. So it says determine the average rate of change between week 0 and 7. Here's week 0, here's week 7. Essentially what I need to do is I just ignore the other information, and I find the change in input is 7. I find the change in output is -6. All right, I can make my own little table if I'm getting distracted, but I can do this. So I get -6 over 7, which is -0.86. Part C says explain what you think the average rate of change means using the problem context. And so in this case, we can't say that his weight changed, it decreased 0.86 pounds per week because we know it didn't. We can't even say that it went down 0.86 pounds most weeks because we don't know that that's the case, right? We know that he lost weight and then he actually gained it from week 0 to 7. So it doesn't mean that he did it most of the time. It doesn't mean he did it all the time. It doesn't mean that maybe he did this like if he pretended to. Really what this average rate of change is finding is it's finding like this hypothetical constant rate. So really what it's saying is if Brandon had lost weight at a constant rate, or if his weight changed at a constant rate, between week 0 and 7, that's very important because if I picked 2 different points, I would get a different average rate. So between week 0 and 7, he would have lost 0.86 pounds each week, right? This is what we call this hypothetical constant. We know really what happened is he or he did something like, I guess that. But if he had lost at a constant rate, so if it was linear, here's what the rate would be. And so that's really what an average rate of change is telling us about a situation. It's not constant, but if it were, here's how we could use it. And so a lot of times we do this because we have situations that aren't linear and we don't have a constant rate of change, but we still want to do something like this. We want to make predictions or estimate what something will be. We don't know what's happening in between, and so we have to use something, and so that something oftentimes is the average rate. This part says use the average rate of change to best estimate Brandon's weight at 10 weeks. So 10 weeks is right here. So really in this case, if I want to estimate at 10 weeks, I'm going to find a different average rate of change now. 10 weeks falls in between 7 and 12, and so I want to find the average rate of change between week 7 and 12. So that's my first step. So when I do that, I get -1.2 pounds per week. So if he'd been losing weight at a constant rate between weeks 7 and 12, he would have lost 1.2 pounds per week. But we know at week 7 he weighed 190 pounds. If he's losing 1.2 pounds per week, we would take the 190, we would subtract off the 1.2 times, right, pounds per week times 3 weeks, and we would get 186.4 pounds. Right, so now we're using that average rate of change to find this estimate. So in general, we can always find the average rate of change just the same way we've been doing it with constant by doing the change in output over change in input. But what we're finding now isn't the constant rate, it's this like hypothetical constant rate. And so that's just a big thing to keep in mind as we're finding and as we're explaining what those values mean.